So then I'm going to share my desktop. All right. Can everyone see my screen?
Yes.
Okay. So let's get started. Go back to the top. So in this session, like I said, we're going to introduce a little bit about OMOP and Odyssey and how we integrate OMOP and Odyssey with ClarityNLP. And obviously, like the main reason we want to do this, because a lot of times we have structured data, obviously, especially with clinical data. So we want to show how we can combine those sources and sort of do sort of full stack data analytics on structured and unstructured data. So there's different things I'm going to go through. I sort of like broke it up into 5 use cases and sort of how we've looked at those and tackled those. I do different examples, but the big areas are how to enhance Clarity vocabulary using OMOP, how you can build more complete phenotypes using structured and unstructured data, how you can find additional features about your patients, how you can maybe compare side by side structured and unstructured data when you're looking for the same kind of thing, and also how you can export your results back to your OMOP database. So just getting started, just do our normal OMOP imports. And in this session, I wanted to introduce Mimic really briefly. I assume that most people who work in this space are familiar with Mimic, but I just wanted to lay it out here because most of the work that we do when we're building out Clarity, phenotypes and test examples, and even some of the other like machine learning data examples that we use the Mimic data set. It's a critical care ICU data set from the Beth Israel Deaconess Hospital from 2001 to 2012. It's been de-identified. The good thing about it is we actually have notes. So compared to a lot of other open or semi-open clinical data sets, we can actually do some actual NLP on it. So that's sort of like one of our main research data sets that we use here at Georgia Tech. So, I'm sorry, what was that?
Just on the same topic, this is Naga Stella. So, along with the mixed data set, there is also IQB2 data set, which is mostly used in NLP challenges. They also have some unstructured de-identified text.
Yeah, that's true. That's a good point. All right. So we'll now introduce a little bit about Odyssey and OMOP if you haven't heard of that before. OMOP is the data model, and then Odyssey is sort of the overall consortium. And basically, it was a bunch of health analytics researchers, including John Duke, who's obviously our clinical lead on our team. He was one of the founders of Odyssey and sort of coming together and to create this open, structured open model around open data model around structured data. So obviously it focuses on things like vocabulary, focuses on things like diagnoses, procedures, drugs, etc. Recently, the OMOP team, people who are building out that model, have built out a NLP table, and basically what the idea behind that is to be able to take data from NLP, so whether you've generated it from a system like Clarity or a system like Medley or CTAKes or whatever system, Lingomatics, whatever system you're using, the idea behind that table is to be able to take data from unstructured text that you've extracted and put it back into OMOP. So that functionality is there, but it's still not a and if you've ever used OMOP, the Odyssey Atlas tool, there's a great tool that the team there has built to build out structured phenotypes. So that's certainly a really powerful tool if you haven't used it before to build out phenotypes around structured data. It's really good at combining features together based on dates and based on conditions and numeric comparators and stuff like that. So that's they've got a really powerful tool to do that, but they haven't really tackled the unstructured phenotyping, which is sort of like what we do with ClarityNLP, and we want to show how we combine our sort of unstructured phenotypes with Odyssey and the OMOP data model to sort of build more robust cohort definitions, and basically take unstructured data, convert it to structured, go back and forth, and how we sort of compare and mesh and analyze these two types of data. So quick note on setup. This tutorial kind of assumes that you already have Odyssey Web API and Atlas up and going. I provided links on those if you haven't done that before. There's a big community with Odyssey. It's all open source project, just like ClarityNLP. It's all on GitHub. They have an active wiki. They have a very active GitHub page. So certainly there's lots of resources there to get you up and going with OMOP and Odyssey if you haven't done that before. As far as what you need, for Clarity, you need to set up the web API URL in your environment file, and I just created an example for that. So we're just assuming if you do this example, you already have that all set up. So first we'll start out with our first use case, and it's obviously like where we would start if we were using Odyssey and sort of data exploration. And we'll start with term expansion, which we've brought up before. It's something that Richard built for us, but there's lots of different ways in Clarity to expand out term sets. There's, like I said, we've done it before. We have synonyms using WordNet. We have lexical variants. So there's lots of different ways you can expand terms to sort of cast a wider net in unstructured data. But we've also integrated with Odyssey to be able to expand out synonyms. You can use synonyms, you can use descendants, and you can use ancestors. It doesn't really give much expansion behind that, but from the work that we've done, we've found a lot of gotten a lot of useful info just from being able to go from synonyms, ancestors, and descendants. So that certainly doesn't give you the full breadth of exploring it with like a visual tool, but it certainly gives you some good results back most of the time. And we use SNOMED by default. You could also use Medra. That would be another if you have a license for Medra. I think we kind of stuck with SNOMED just because of that licensing issue. But in this use case, what I wanted to look at was patients with low platelets, and that'll kind of be a theme for a little bit. Then we'll move on to some other domain areas. But in this case, say I'm looking for related conditions to someone who has a low platelet count or thrombocytopenia. And I just picked a few of these. I didn't want to do all of them because it would be super long, and you kind of get the idea from the ones I did. So some of those areas that I wanted to cover was bruises, red or small dots called petechiae, and nosebleeds or epistaxis. So let me get... So what we've done here is basically just define two term sets based on those list of synonyms. And I did a set based on bruising terms, and I did a set based on bleeding and nosebleeds. And I'm not a doctor, obviously, so I'm sure some of this is wrong, so you can refer to John Duke if you need a real doctor for any time. So yeah, so for bruise, it's a common word. I just did verb inflections. For purpura and contusion, I wanted to use the Odyssey synonyms because those are medical terms. Same thing with epistaxis and petechiae. So once I ran this, let's see what results we get back. Okay, so we get the verb expansion with bruise and bruising. We get different terms back. For purpura, for contusion, we get some of the same synonyms that we already have, which is bruise and bruising. Interestingly, we didn't get any synonyms back for epistaxis, but we did get some back for petechiae, so we'll definitely add those in. So we can see that SNOMED gives us some weird stuff that's not always useful, but we'll just filter those out for now. If you have Odyssey Atlas, you can certainly explore these things in finer detail. So this is a screenshot of that tool. I can also bring it up. So if you go to the Atlas tool, and I provided links to the public one as well. I think it requires a login now that they've added some security. So I'm just going to point to the Georgia Tech one. So let's look at some of these terms. I can do some exploration as well. So if you find that the Clarity term expansion, it does a pretty decent job of finding some additional terms, but if you find that maybe there's more terms you want to add, you can certainly search for them in the Atlas tool, and it provides lots of different variations that you might be able to use. And kind of like I mentioned, Medra is pretty good at finding terms that are sort of more realistic in terms of like linguistically, sort of how things are expressed. So using Medra is certainly a good way to explore these terms, and you can do the same kind of thing and look at related concepts. This is just more of a graphical tool, so just wanted to point that out. And you can save these, you can export them, and then write and use these and copy back to Clarity if you wanted to do that too. So in addition to these term expansion tools, I did want to point out that Odyssey has a really nice UI for exploring vocabulary using Atlas. So now that we have those terms, we can look and see how it compares to structured data. And in this case, I'm not doing like a one-for-one comparison. So we have our terms. We're still looking at low platelet count patients. And how does that compare with the symptoms that Clarity can find based on the conditions we just discussed with a cohort that we defined in Odyssey, and I'll go through that. Before I do that, does anybody have any questions about vocab or anything thus far? Okay. So first thing, let's look at the Odyssey cohort. So if you go to the Atlas tool and look at cohort definitions, John nicely built some of these cohorts for me, so I didn't have to, okay, yeah, that's fine. Didn't have to build them. So this is just a pretty simple low platelet count, and you're just finding a measurement of platelets, and it's less than or equal to 100. So similar to like where you'll see later on, we have that syntax in Clarity where it's like where less than. This is just more of a graphical phenotype builder tool. So this is, sort of comparing and contrasting Clarity with OMOP again. And this is how you would build structured phenotypes in Odyssey. So it has a nice tool to export. You can copy that to clipboard. You can see the JSON, which gets shared, which you can share with other sites who are running Odyssey. You can see the SQL. You can see what it's doing behind the scenes. But you can also see a text view, which is kind of like the way I like to look at it. And you can pretty much just see it's a low-ink term where the platelets are less than 100. So now that we've done that, let's look at what Clarity can find. So we've set up a cohort. We'll look at that in a minute. Let's look at what conditions that we found. So now that we've expanded our terms, we've got this set of conditions. Let's see what we can find. And in this case, I didn't do a full set of document notes, only for time space, because I wanted to have these run a little faster. So I just ran them on physician notes. Obviously, for more realistic tests, I might want to run it against a larger set of notes or all the notes in Mimic. Certainly add nursing notes or some of the discharge summaries. So I just wanted to say that might be limiting some of the results that we see. So in this case, I just took our bruising terms and filtered out some of those weird ones that SNOMED gave us. I've added some bleeding terms that we found, including some of the ones that we found through the synonym expansion. And then I just did the basic provider assertion, which is our most common phenotype task, and we've talked about it a lot. And it's basically just like it's a non-negated mention of a term. And then finally, I just wanted to see what patients had both bruising and bleeding. And I ran that. I'm not going to run it again just because it's kind of a bigger job, but I will bring it up for you. just so you can see. So you can basically just see we have patients who have bruising. Let me just bring back this simplified view. So let's see, term, PQL feature, and sentence. Maybe that'll be a little bit easier to read. Yeah, it's a little bit easier to read there. So you can see this is just, I can pull up a few more. So you can see Clarity just found terms related to contusion, bruising. So these are just the first few. So obviously, like, they're all the bruising ones sort of pop to the top. So it looked like these are valid ones for patients with bruising. Similar kind of thing if you wanted to look at just the patients who had bruising and bleeding. So the difference here, so when you get back Clarity results, you get back two types of results in your as a CSV. You get back intermediate results and you get back main results. And I know we kind of have thrown these around in the past, so I just wanted to sort of take a break here and explain what those are. So when you do things like defines here, these are basically low-level tasks that Clarity runs. You can sort of think of them as primitives in Clarity. Obviously, they're not like the lowest level primitives, but in terms of what Clarity's doing, they're sort of primitives. And it's basically anything that's not annotated with a final. And what that's basically doing is, like, these are your raw results that Clarity found. You can also annotate these with final, and then they'll get moved to the main results CSV. But for the most part, these types of things are just in your intermediate CSV because they're just temporary. They're not temporary results, but they're intermediate results to sort of creating your final cohort. And the idea behind the main results CSV is sort of that's your final cohort. That's your ending phenotype. And those are always denoted with final. And then that's sort of the notation that we use. So intermediate is sort of things that aren't final, things that are more raw results, and final are, you know, what you're labeling as your final phenotype. So what I first showed you was the intermediate data set. This next one we can look at oops. Let's see. In this case, we have, because these are joined together, we have both. So probably shouldn't be doing stuff on the fly here, but let's see what happens. All right, I'll just go back to what I had. But these are joined together. So you can see these are people who have bruising and bleeding. And basically you can look at this person's coughing blood, epistaxis, and also contusion. So these are people who have symptoms that might be related to having a low platelet count. You can also look at the result viewer and explore these more. It's a little bit easier to view these in the result viewer. So if I were to go there, and I provided an example here, but if we go back to our cohort, we can look at that, and got, which one did I say this was? 539. So you can find sort of, there's a lot of patients here with a lot of different events, but these are patients who have both bleeding and bruising, and you sort of get the full tree here, and you can see, oh, this had a recent fall with bruising and a nosebleed. So this is sort of how Clarity combines these features together. So obviously these people don't have low platelets, but they're people who have conditions that are related to having low platelet counts. So if you had bruising and bleeding, it might be a thing that you would look for to see if this person, you might want to measure their platelets. So that's sort of how we explore. So now that we've done that, I've already shown how we did this in Atlas. We have our strict measurement of platelet counts less than 100, less than or equal to 100. I showed you JSON. You can export that. So now that we have that, we can take our cohort of people with a measurement of low platelet count, and then we can take symptoms that we found in Clarity and compare those. So in this case, this is what we get back from our Odyssey cohort, and it's basically just like start dates, end dates, and the patient ID. We can see how many patients we have. We have 8,031 patients in our low platelet count, and we have 4,684 in our intermediate. So people who have bruising or bleeding. If you wanted to look at both, we'll look at that in a minute. So how do we compare these? So there's lots of different ways you can compare these data sets. Obviously, we end up with two sets of patients. So what I wanted to do is do some sort of set operations and build out some Venn diagrams so you can see how these cohorts compare and how you might be able to build phenotype sides on either side. So if you're coming from NLP, how you could integrate structured data and back and forth. So this is a function that I built to do that. And then once that function is ran, we can look at patients with bleeding or bruising. So in this case, I'm looking at just the raw features. So they either they have a mention of bleeding or bruising, and then I also compared it with low platelets count. So we can see the sizes are quite a bit different. We only found 184 patients in Clarity who had a low platelet count. What might be a reason that these numbers are so low? I should have put my ideas out there. If anyone has any other thoughts on that, feel free to share it. Again, we're pulling from mimic to mimic. Maybe this isn't a good, medical use case. It's certainly just something I was trying out. But it's interesting to see sort of how different the numbers are. So some of the reasons might be that we only found 184 patients who have a low platelet count and they have those symptoms. Is maybe we don't have all the notes on those patients in Mimic. Maybe we only looked at physician notes, so maybe we should expand that. And we didn't really specifically look for low platelet counts or even all the symptoms. We just looked for bleeding or bruising. So maybe that's just not a good example of how to compare those phenotypes. But it's certainly interesting to see where those cross over. So the next thing we looked at is patients who have bleeding and bruising. So that's our sort of final cohort in Clarity. And how did those turn out? So the difference is even more stark. So we found very few patients who had bleeding and bruising and were in the cohort. But we can see about half of those that we did find were in the structured cohort. So it's hard to say why this is, but we know that Clarity did find 22 patients who had bruising and bleeding. 22 of them were in this cohort. 22 of them were not. Could just be coincidence. There could be all sorts of medical factors. There could be data reasons, like I mentioned. So there's lots of things to look at with your data when you're sort of doing these exploratory things and comparing structured and unstructured data. Like I said, this isn't a true pairing. The next example I do will be more of an even pairing, so you'll get to see the results a little bit more balanced. In this case, I was just looking at symptoms versus a condition or a measurement to be more precise. So there's your first example on how we compare Odyssey and Clarity. We'll dig into a few more examples and sort of build out these examples further. But does anybody have any questions? Okay, so Bake Off is like our classic. Wanted to have a cake there. Like, just kidding. Haha, no cake. So Bake Off is sort of our classic example that we've done. You see lots of like posters and papers on it when you go to Odyssey or when you go to like OdysseyCon and AMIA, people comparing things they found with NLP versus things they found in structured data. And it's obviously like a common problem in clinical informatics that we're looking to see how we can compare and contrast and find patients in each cohort and see how they map with structured data to unstructured data. This is sort of a more classic example of that. So we're sticking with our low platelet count example, but in this case, instead of focusing on a symptom like bruising or bleeding, I did the terms exactly in Clarity. So I did low platelets, and thrombocytopenia. And I ran that, and I also, in this case, I added a lot more notes. So I added nursing notes, and I added discharge summaries. So this should give us a lot wider net. I'm not going to rerun it because it's a larger job and it won't finish, but I'll take the previous runs that I did, and let's look at those. And I wanted to see how big this was too. So let me... Let's see. So we've got 12,000 rows. That's not necessarily unique patients. It's just 12,168 instances of mentions of thrombocytopenia or low platelet count. So here's example of thrombocytopenia. Consistently low platelet count. I would hesitate to suction due to low platelet count. So we can see these are valid examples that Clarity found for low platelet count. Let's see how they compare with our Odyssey cohort. You can kind of see a preview, so I'm kind of ruining it. But you can see we found a lot more crossover. The intersection is much larger between these two. It's still not as big as it could have been. So it's still kind of interesting that the numbers are so skewed towards the structured data versus the unstructured data. But what is interesting on this one is we did find 435 additional patients. So maybe, if you have a really rare condition, or, this is an example of maybe if you had a rare condition or something that you were having a hard time finding in structured data, this might be a way to expand out that data set. But in this case, like I said, we're just comparing more apples to apples, closer to apples to apples. So let's look at some examples why Clarity didn't find some of these. So I wanted to, and I manually went ahead and found them. We do have some other tools, and I'll show those briefly. So we do have some other tools that we've built here at Georgia Tech that you can sort of search these terms. But I went ahead and pulled them up, and I don't know if I'll be able to find them anyway. But like I said, like if I just search for, thrombocytopenia, I can sort of find patients and review the notes one by one instead of doing it that way. So I looked at these patients. I found out what was going on with them and try to find why maybe they had mentions in Clarity, but they didn't have a low platelet count in the structured data. And it's not really clear why. Some of this might be the diagnosis of thrombocytopenia. Maybe they had a low platelet count measurement, but they didn't have the diagnosis code. And in this case, it looks like maybe just a miss. For whatever reason, the person didn't have a measurement in the system. So we can see, looking at some of these examples, they look to be valid cases of people with low platelet counts that Clarity found. So why weren't these found by the structured data? It's hard to say. Maybe we need to add more terms to the structured side. Maybe this is data that was only captured in clinical notes because it was from another visit or something like that. So yeah, these are just things to look at when you're sort of comparing structured and unstructured data. I only did 3 examples here, but certainly you could look at a lot more. I did a similar thing with the Odyssey difference. So people who were in the OMOP cohort, but they weren't in the Odyssey cohort, but they were not in the in ClarityNLP. So what I found was I just looked at 3 patients. 2 of them only had a few notes, and the third one only had 15 notes, but none of them mentioned low platelets or thrombocytopenia. So for whatever reason, it didn't mention in the notes. So I manually reviewed these, and I didn't find anything. So obviously, like, looking at 3 patients is a pretty small sample. It doesn't really give us, a good case for one way or the other, but it does show us that we can certainly beneficially maybe expand the cohort sizes on either side if we're finding that we're not getting enough results or the kind of patients we're trying to find. This is using structured and unstructured data in a bake-off format is certainly a way to build out and expand these cohorts, especially when we're trying to find additional criteria. Obviously, where Clarity shines is stuff that's not found in structured data. and rare conditions, things that might get mentioned but maybe don't have diagnosis code in the traditional way. So that's it for Bake Off. So my next use case, and I'm kind of doing okay on time, so if anybody has any questions, I can ask questions, or we can answer questions, or we can take questions at the end. Okay, so on to the next one. So moving away from our low platelet count patient set, we look at patients with atrial fibrillation, and that's sort of looking at a rapid or irregular heart rate. And these are patients, we're going to define them in Odyssey, and then we're going to see what things we can learn about these patients given information that we find in Clarity. So let's go back to our friend Atlas and go back to the good old cohort definition and go back. And see, I don't always know how this thing works, but working on it. So AFib, it's essentially a very simple cohort as well. It's a condition occurrence of a person with atrial fibrillation, and it's basically just someone with the SNOMED code of AFib. So looking at that, these are people who've been diagnosed with AFib, irregular heart rate. So since AFib is related to heart rate, let's see what vital signs we can extract from ClarityNLP and say, why do we want to do this? Well, Clarity's pretty good at extracting vital signs. This is another thing that Richard built for us. It's really great at finding and pulling out these sort of values. So that's certainly where it shines. If we have a specific conditions that we're looking for and we're trying to extract values related to that condition, and maybe for whatever reason there's not structured data around that, this is another area where Clarity really shines and sort of joining, OMOP and Clarity together. So again, just looking at these patients, here's an example. How many patients do we have in this cohort? We've got 10,271. Ooh, another thing I was going to show you guys, in the Atlas tool, if you haven't used it before, you can also generate, and it'll go out and scan, and you can see that the numbers are the same. So we're getting the right patients back. So we're getting 1,371 patients. So now what I want to do is find vital signs on these AFib patients, because maybe I want to see what trends I can find, what can I see in the heart rate in heart rates of AFib patients. What more can I learn? In this case, basically just looking at heart rate and blood pressure. There's one important difference about this NLPQL, is I'm running on a very specific cohort. So I'm saying, Odyssey, get me the cohort ID. It's 358, which is the same here. So we're pulling from cohort 358. And what this does, it will basically run these value extractions on just that cohort. So it's really powerful if I just want to limit my Clarity execution down to one set of patients. So looking at two things, heart rate, BP, I just did a pretty wide range of values. I did pretty basic terms. I did HR and heart rate. I did blood pressure and BP. So I ran that job. Let's see what it found. It's going to be a little bit bigger since I ran it last time, because I think it was still running. But you can see these are, there's always one that comes first, because, obviously when the job kicks off, there's the first batch that always gets ran. But these look like, I think these are the heart rate, because heart rate was first. And basically, we can see the results that came back, how big it was. So it increased a lot in size from when I ran it yesterday. So we have 25,730 observations of heart rate and blood pressure based on these 10,271 patients. So that's pretty interesting. So let's just look at some of the values if you wanted to compare. So 110 in this case is the heart rate. So it's ranging from 110 to 170. I wanted to make a note about that. So you'll see, and it doesn't, Pandas doesn't show all the columns, but Clarity does but this one is there. So when there's a range, Clarity does extract the full range. It just pulls out the X value as the default value. So just wanted to point that out. So even if you have a range in the vital signs, Clarity will pull both of them out and give you both of those values. So that information doesn't get lost necessarily, but the first value is the default value, but both of those are in there. So we have BP, we have, in this case, we're just pulling out heart rates, because like I said, all the heart rates kind of floated to the top. But this looks like valid. All these people have AFib. This is a person with AFib, heart rate in the 90s. Low pressure given, Coumadin given, so that's a blood thinner, obviously, heart rate controlled. So this makes sense. We have AFib cohort. There are people having problems, heart rate getting controlled. It's an irregular heart rate. So these are the kind of things we would expect to see, and Clarity's doing a good job of extracting the values. So all good stuff. So now that we've taken out some values, we can just look at certain aspects. We'll start with heart rate. Like I said, heart rate kind of bubbled to the top on this one, but we can do different things and sort of explore. But what I wanted to do in this one was sort of plot a histogram and heart rate. Obviously, this doesn't give us anything super new or super surprising, but it does give us, just some interesting statistics on this data set. So in this case, just wanted to pull out patients with AFib, AFib patients, and just pull out the heart rates. So let's see how big that is. From our 25,000 and some, looks like they're all heart rates. So maybe my job just went kaput after the heart rate one. So anyway, they're all heart rate. So now let's look at those. Let's look at the distribution. So basically I just did a simple histogram based on frequency and heart rate. So it's kind of like a curve, if I had to guess, not having any medical knowledge on this. Kind of what you would expect. I did bends of 25. You could change that, obviously, and get more, precise results. Sorry, let's go higher. So obviously you can see big peaks there. Obviously people are like rounding to the tens and stuff like that. But it's kind of what you would expect to see with the distribution of heart rate. But it's certainly interesting, a thing to look at, a way to look at getting features on a specific cohort and finding more about them. So in this case, we're looking at AFib patient heart rate is interesting to look at. Obviously, you could look at specific patients, do more plots over time. That would be interesting too, more time series analysis. Certainly a lot you could do with this, but it's sort of interesting to see, in this case, how you combine structured cohort with ClarityNLP. Before I get to my last example, does anyone have any questions so far? Okay, so we are on to the very last example. We've made it through to use case number 5. So you can see from all the stuff that we've done and all our previous cooking sessions, and maybe if you've been in our demos, Clarity does a pretty good job of extracting features from clinical text. What it can also do is write data back to an OMOP database. This is something that we've built recently. Shirag, one of our students, built this for us. It is a push-only function, so we added it as a button on the user interface. And the general rule is we don't necessarily want ClarityNLP to be written back to OMOP, because we consider that a source of truth. And any kind of analysis you do with Clarity, obviously you want to do some validation on it. So don't, we obviously encourage you to do chart review, and that's why we have built tools like the result viewer. We have tools like the chart review tool. So we certainly built lots of tools around being able to review and validate these cohorts. So that's something we want to obviously encourage before writing this data back to a source database. But depends on what the use cases are. If you're just training a model, maybe you're okay with looser definitions, and maybe you don't need that strict gold standard. Maybe a silver standard is better, is okay. So yeah, just a general, like, it's this push only, you should validate the data that Clarity generates. So for this feature, we had some patients with pneumonia. We wanted to extract temperature, use the result viewer, and then write that data back to OMOP. So in OMOP, we can pretty simply define patients with pneumonia. I put the JSON here in case anybody wanted to see how we define that. It's a pretty simple cohort. Let's go back to our handy Atlas tool. So if you look, it's just people with pneumonia. That's all it is, people with the SNOMED code of pneumonia. Let's see how many patients there are. So there are 4,438. So we found 4,438 patients with pneumonia in Mimic with that diagnosis code. So look at that patients. Let's see, make sure it's all the same. I need to run this one first. All right. So we ran that. We got the same results as Atlas. We're doing good. All right. So we can also look at we created another cohort with pneumonia with fever. So these are patients who've had a mention of fever. Let's see how many we have. I think it should be 0 because I cleared it out. Let's see. Still running. Still 0. That's what we'd expect. There are none. There are none. Okay, so we don't have any matching patients with pneumonia and temperature. So how do we find patients in Clarity who have a temperature? So this is another great use of value extraction. Clarity is really good at pulling out temperature. In this case, we look at temperature terms on our pneumonia patients, and we just limit it to a range. And then finally, how we define fever is a temp value greater than or equal to 100.4. So let us see what Clarity has found. So Clarity found that temp 97.1, temp 98.4, temp 101.2. So these are patients with pneumonia, and we found their temperature terms. So say we want to write this data back to OMOP. So now that we have that data, we can write it back in the result viewer using the user interface. So a concept I want to use here, which I have it pre-saved because I knew I would forget it, but it corresponds to a Loent code for body temperature. And now that we have that, so let's look at our friendly cohort in the result viewer. So let's look at 546. Let's see. So we didn't have any results that it found yet. I think it was still running. But we can go ahead and export the temperature back to OMOP, ideally. So if we click export, what we get is temp. This will dynamically pick based on the features that you have. So if you have different features, obviously they can map to different concept IDs. Then I'll paste in my concept ID, which is the OMOP concept ID that maps to that Loent term. And then this is a measurement. You can also do conditions and observations. And then you click export. And then sadly, what I have learned this morning as I was preparing my demo is that we need a hole punched in the firewall, and I wasn't able to get this to work. So I sadly don't have this all working in demo mode, unfortunately due to firewall rules. But you get the idea. I have it running locally, and it may work, may not work also. Let's see, but you should get that result back to say that it successfully exported, and then you can see hopefully some results. And I was having trouble getting this to work locally as well, unfortunately. So there's obviously some firewall rules we need to work out on our side. But most of the wiring is there. It should work locally. And the idea behind that is once you have a concept, then you can write it back to OMOP. So once you have these validated temperatures, you can write them back to OMOP, and then you'll be able to find pneumonia patients with temperatures. So that is all I have. I think that is sort of covering a lot of the OMOP and Odyssey integrations that we have. I'm sure we'll continue to build out more features relating to OMOP and the Odyssey community because we're just tightly integrated with sort of work that they're doing. So I just wanted to give a shout out to them and sort of show how we've been able to integrate OMOP and Odyssey and use sort of their tools to enhance clarity and vice versa. So with that, does anybody have any questions?
Yeah, this is Sergio. So my question is, first, thank you for this presentation, and I'm very impressed, and I would very much like to be able to reproduce what you have demoed today. I'm assuming that in order to reproduce this, you have the data source, in this case, Mimic, in the OMOP CDN format. Is that correct?
That's correct. And we have, I think there's been work to normalize it to OMOP, but we've certainly done it here at Georgia Tech, so we could help. It's not our team. There's another team that's done that work, but we could certainly help people with instructions on how to take Mimic and convert it to OMOP. There may be open source instructions out there already, though. But yeah, we can certainly help point you to the right people who could help with that.
Okay. I'm asking because at this time, the implementation of the Odyssey tools in our platform is still incomplete. There have been some technical difficulties that probably worth to mention in this call. But we have two data sources in the OMOP common data model format. Not because we need to do the transformation, but we are building the capabilities to do the transformation. It will be helpful to share the ETL. But we are trying to address some issues because of the fact that we are hosting our data in Impala and the CD connector package that doesn't support Impala with serverless authentication. And that's something that I have been working on actively. But the point is that I'm really looking forward to being able to reproduce the results. So I expect that during the next month we will be able to update our implementation of the Odyssey tools. And so it will be okay if I reach out maybe in around a month once we have addressed these issues, so you can help us reproducing these once we have the data loaded in OMOP format.
Of course, yeah. Yeah, you can reach out on Slack or email, either one. And if we're not the right people, obviously with Clarity, we're the right people, but if there's OMOP-specific issues, we can try and help find people to help with those too. But yeah, of course.
Yeah, also, are you planning to attend the Odyssey Symposium this Friday?
I will be there just on Friday. I'm making a day trip out of it. Richards and John and Trey are going to be there.
I'm going more afternoon.
Yeah.
Assuming the hurricane doesn't stop me.
Yeah, assuming we don't get rain, insane amounts of wind and rain.
It's
But
really good right now. It's like really bad.
it's not good.
Yeah.
But yeah, we're planning to have a crew there, and John's heading straight there from vacation. So.
Okay, and I plan to be there. Actually, I'm attending not only the symposium, but also one of the basic tutorials and one of the advanced tutorials. So it will be like we can.
I think I think Trey will be there for some of those. I think, and then John may be there that day as well. I'm not sure when John is arriving, but I'm pretty sure he's arriving on Thursday as well.
Yeah. Okay. Great.
This is Nada. I This is my first time attending this Clarity Cookout sessions. So I'm trying to understand, is Clarity, do we have to have the data in the OMOP format in order to use Clarity? Or can we have the data, like if you have tons of unstructured data, can we just use Clarity on top of that?
Yeah, so in general, you don't need any structured data to work with ClarityNLP. It's just dealing with text. For this demo, we just wanted to show how you could link those two together. But we certainly have some previous notebooks, and we have a lot of documentation as well. But yeah, you just need unstructured data, and you are good to go.
Got it. That's what I thought. Okay, so is this the link to just get acquainted with Clarity and how to use it?
Yeah, so this is the link to the documentation. We've tried to write a lot of documentation. I'm sure there's areas that we missed on, so certainly give us feedback on GitHub or another way. You can pop me an email. You can also reach out on our GitHub repo. This is our GitHub repo. And we have all our projects that we work on. ClarityNLP is obviously the main one. So.
Okay. And is this the open source or is it licensed?
It's open source.
Software?
It's all open source. It's MPL license.
Got it. Okay.
Hey, Naga, can you tell me where you're from? I don't recognize your name.
Sure, definitely. So, by the way, so I got this link from John Duke's LinkedIn.
Okay, awesome.
So that's how I joined. I'm connected to John Duke. So
okay, no worries, yeah.
I work for Anthem here in Atlanta.
Okay.
And we are into healthcare, obviously, healthcare insurance sector. And we do a lot of work with the claims and EMR data. And then one of my interests is to do NLP on the unstructured EMR clinical text.
Okay, awesome. Okay, thank you very much. So yeah, I'm happy you found us. Yeah. But yeah, all you need is unstructured data.
I do have tons of questions, Charity, so maybe I can send out an email.
Sure.
Maybe we can think up more. I don't want to waste everybody's time and asking some fundamental questions that I'm not aware of. So maybe we can think up and then see how we can collaborate.
Yeah, absolutely. So you can reach out to myself and reach out to John as well, and we'll help answer your questions and figure all those things out.
Sure. Thank you.
All right. Well, we are 6 minutes off the hour, so I think I will wrap it up. I think you can email me if you have any questions. My email address is in the invite, I think, if you got it. If you didn't, I'll put it here really quickly. It's charity.hilton@gtri.gottech.edu. You can also reach out on GitHub, post an issue, different ways. You can reach out through LinkedIn. However you find us, we'll try and get back with you. So thank you all for listening. Have a great rest of your week. We're going to try and not get blown away by a hurricane. I don't think we will. We'll just get rain. We should be fine. But anyway, for those of you going to Odyssey, some of us will see some of you at Odyssey. So looking forward to that as well. All right. That is it. I'm going to stop sharing and sign off. Okay, thanks guys. All right, bye.
Thanks for using WebEx. Visit our website at www.webex.com.